In this lesson, I'll show you two examples on how to determine molecule polarity. The first of two questions reads, determine if NH₃, ammonia, is polar. The polarity of molecules depends on two things, its geometry and the electronegativity of the atoms. So with that being said, we need to come up with the molecular geometry of NH₃, and we start with the Lewis structure. The Lewis structure for NH₃ looks like this. We have a central nitrogen, and that's surrounded by 3 hydrogen atoms. The nitrogen atom has a valence of 5, and each of these hydrogen atoms has a valence of 1, which adds up to 8. So we have 1, 2, 3, 4, 5, 6, 6 electrons used up, and to make this a complete octet, we'll put a lone pair on the nitrogen. What you see on your screen is the Lewis structure for ammonia. From this, we can determine the amount of electron groups, and that's determined by the bonding groups. We have 1, 2, 3 bonding groups. 1 lone pair right here, and adding these up we end up with the amount of electron groups, which is 4. Using this information I can now find out the molecular geometry, and if you look right here, if you have 4 electron groups, 3 bonding groups, and 1 lone pair, you have a molecule that has the geometry of a trigonal pyramidal. And a trigonal pyramidal looks roughly like this. Next, we have to analyze the electronegativities. Nitrogen is a lot more electronegative than hydrogen. In fact, nitrogen has an electronegativity of 3, whereas hydrogen has 2. So we know that the electrons will be pulled towards the nitrogen. Now, since this molecule is 3D based on the shape that we found, as shown on your screen here, if we draw vectors showing the tendency of electrons towards the more electronegative one, we'll have vectors that are going in this direction, and this direction. This suggests that if we add up the vertical components of these vectors, they will all be oriented up. Therefore, this molecule is considered polar. So it's polar for two reasons, because of the electronegativity differences and because of the shape. On the other hand, if you had a molecule, let's say BH₃, this one would not be considered polar because if you come up with the electron groups, it would be a trigonal planar. Trigonal planar means that all of the atoms are on a single plane, so if you add up the vectors, they would actually cancel out, and you wouldn't get a dipole. Now let's move on to question 2. Determine if CF₄ is polar, CF₄ being carbon tetrafluoride. Let's quickly come up with the Lewis structure. We have the central atom being carbon and fluorine surrounding the carbon. Fluorine has 7 valence electrons, so we have 28 in total. 4 times 7 plus 4 from this carbon, that's 32. 1, 2, 3, 4, 8 are gone already, so 24 left. Let's distribute these electrons to the peripheral atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. The amount of bonding groups here are 1, 2, 3, 4 bonding groups. We have no lone pairs. Adding this up, we end up with 4 electron groups. Using this chart, 4 electron groups, 4 bonding groups, and 0 lone pairs gives us a tetrahedral. And according to this 3D illustration here, we end up with the molecular geometry of a tetrahedral. Now let's discuss electronegativities. Fluorine is much more electronegative than carbon, so we would expect that the electrons are being pushed towards the fluorine atoms. On a 3D scale, what this would do, if we were to draw with these vectors, their directions would all cancel out. So there wouldn't be one prominent direction where those electrons are heading. So we would say that CF₄ is nonpolar. And there you have it. That is how to determine molecular polarity.